Hi, good morning everyone. So yesterday we had discussed about some of the basic introduction to data analysis, where we had said something on representation of data. So we had looked up into numerical representation of data, and as far as statistics is concerned, we can represent data in two ways. One is by the usual numerical representation of data, and another method is by the usual another method is by pictorial representation of data. Okay, so there are two representation of data. One is by numerical method and another one is by pictorial representation. Okay, so in most of the cases we see that the representation of data is by a numerical method. Okay, most of the time it is by numerical method, and at a certain situation when the we see that when we represent a data pictorially, it helps common man to analyze the data. Moreover, it helps in understanding what does the data mean to common people. So main use of this pictorial representation is that it makes sense to the common people. So this is the main use of pictorial representation of data. So when we say in the numerical case, we just say that it is average mark. So common man would not understand what are these terms. So the main use of this pictorial representation is that uh, it is more understandable, or it is more easy to understand for common people. Okay, so another method, we will move on to another method, that is pictorial representation or graphical representation of data. Okay, so we will move on to the next section, that is graphical representation of data. Okay, so there are many methods included. There are many methods which are used for graphical methods, and some of them include line graph, bar graph, then pie diagram, then pictogram, then mapogram, histogram, frequency polygon. There are many things, so we will discuss in detail. Okay, first we will move on to line diagram. Okay, line diagram. So the name itself says that here the frequency the frequency of the data, or frequency of the variable, are represented by line of the proportionate length. Suppose that I have x as the variable for male and as well as female in a classroom, and I suppose that the number of males, which I call it as frequency, and corresponding to male I have 20, and to corresponding to female I have 10. Then we can represent the line diagram such that here I take x-axis as male, and here I take it as female. So I scale them as 10 and 20. Here the in line diagram I do in such a that I just plot a line over the variable male corresponding to its frequency. I hope the idea is clear. This is the main idea behind line diagram. Okay, this is one example of line diagram. Okay, so we may write in a line diagram, in a line diagram, frequencies are represented by lines of proportionate length or proportional length. Okay, this is the main idea behind the line diagram. Okay, Then another type of representation is by bar diagram. This may be familiar to you, bar diagram. Moving on to next one, bar diagram. So what happens here is that in bar diagram frequencies are represented by rectangles. Earlier it was in the case it was lines, whereas I think that clearly, okay, now it will be more clear. So here instead of lines we represent it by bars. Okay. So in case of earlier example, in male we will represent it as one bar and female will represent it as another bar. Okay, male, female. So these are things. So we will write what does bar diagram means. Okay, in bar diagram frequencies are represented by rectangles, or in bracket you may write it as bars. Okay, corresponding or proportional to its proportional represented, sorry, let me make it more clear. Frequencies are represented by rectangles or bars of proportional length. Okay, this is the correct definition. Okay, this is the main idea of bar diagram. Okay, I think that you may be clear of that. Okay, so further we note that this bar diagram can be further divided into two. One more it can be divided, that is subdivided bar diagram. So we will explain with an example. Okay, so what is the concept of what we say is subdivided bar diagram? Okay, so here what happens is that suppose that I have two classes, class 1 and class 2. Okay, class 2. So in class 1 and class 2 I have students female and male. Okay, so here I have 20 and 10, whereas in here I have 10 and 20. So I have to represent this. Okay, so what I do that in one diagram itself I represent class 1, another diagram I represent class 2. So here it is number of females is represented by our shaded region, and here number of females is represented by shaded region. So I write in such a fashion that number of females, and this section is number of males. So in this also we can consider the example of this is an example of subdivided bar diagram, where the first bar represented one thing and another bar represented the another thing. Okay, this is main idea behind. Just you want to know what are different criteria or different methods by which you can represent a data. Okay, this is one example of that. Moving on to another method, that is by pie diagram. So I will explain what is the concept of pie diagram. So it is a circular type thing. Okay, representation is by circular. So we represent suppose that as it can be represented as male and female itself here. So in most of the cases or it will be female or male, like this representation, where it is a circle type representation. There are many methods, and one form is our pie diagram. Okay, then we can write something on pie diagram. This type of where this shaded region is nothing but as in the case of earlier, number of females. So while writing, we will come to know uh, what are different techniques associated with the pie diagram and how we will calculate the frequencies associated with the pie diagram. Okay, so here we see that in pie diagram, frequencies are represented by proportionate areas within a circle. For example, suppose I consider the earlier example where in particular example where male had 10 and female were 20, and total I have 30 students in a class. So I want to calculate the area. How should I represent? So the formula is proportionate angle. To how to calculate this angles area or angles area. So here I write the proportionate angle is obtained as it is by individual frequency divided by total frequency into 100. Okay, so in the case of male, in the present example I have 10 males and I have 30 females, and I have total it is not into 100, it is into 360. Okay, into 360. Okay, so I obtain the angle to be I obtain the angle to be 3 1 2 3 2 okay 120 120 okay 120 degree Celsius. Okay, then for female, since there are only two categories and it is 360 and it is one of them is 120, so you can calculate by earlier method as 20 by 30 into 360. So here also 20, it will be 240 clearly. So the proportionate angle will be this angle will be 120 degree and this angle will be 240 degree, and it represent male and this represent female. I hope that the idea of a pie diagram is very clear. So it is used for the representation of data. So if more than two items come, then also we can find out by the following ways. So one more will come, so correspondingly there will be three areas. One will be like this and one will be like this and another will be like this. So there will be three areas. Corresponding to three areas, we can find out the proportionate angle by this formula, that is individual frequency by total frequency into 360 degree. Okay, I hope that the idea of pie diagram is clear to you. This is the way how we calculate the pie diagram. Okay, so next method is by pictograms. Here frequencies are represented by certain pictures or symbols. Okay, here we will write here frequencies or signboards are represented by symbols or pictures. Okay, so for example here you may take an example of a church. For example, for church it is represented as like this. In some surveys and all, we can represent church as like this, and for example temples as like this. We represent in some survey maps. If you look into some of the survey maps of government, you will locate these symbols for temple, church and mosque as like this, like these things. Okay, this may be some of the representation of mosque, temples, like this. Okay, okay. Like this will be in some technical surveys or some surveys, if you connected to land surveys and all, then these types of churches and mosques will be represented in similar fashion. Okay, next method is by, these are some simple methods because these are not so important, but you should know what are the different methods which are there in the contest. So this will be never asked in the examination, I hope so, but usually it is not asked. But raw data and pictorial representation is not asked, or graphical method is usually not asked. If at all it is asked, then it will be for, in the case of histogram it will be asked, because histogram is an important one. Okay, so next we move on to mapogram. Mapogram is nothing but it is mostly used in Department of Statistics where surveys are concerned. So if you have an election map or something, or land surveys, this will be very important. These types of lands where constituencies are or district are marked in such maps, this mapogram is nothing but graphical representation of a state by maps. It is nothing but maps. Okay, so it is we may write it as it is presentation of data. So what are there in that districts will be in that district, these things will be marked in maps. For example, so suppose in the case of Kerala, suppose that this is the map of Kerala, some agricultural lands has to be marked. So if I mark like in this fashion, then this is areas where agriculture has been is being carried out. Okay, and most of the case Palakkad is the district where agriculture is done mostly. Okay, so we may mark some district like that. Okay, so this may be the map of Kerala. Suppose that, so we mark we mark the agriculture land, which is the area where agriculture is done mostly. So these types of representation can be done in a mapogram. Okay, so it is a presentation of data within the geographical map of a nation, state or district, then even panchayat also, that you need not write. Then okay, these are the thing. It is presentation of data within geographical map of nation, state and district. Example, agricultural areas marked in a state map. This is the state map of Kerala, and we mark the agricultural land concerned to the map, concerned to Kerala, not the map. Okay, this is also one method. Okay, these are the basic ideas behind this one. Then next we move on to the histogram. Histogram is an important one that we will discuss. So the main idea behind histogram is that we take so in the case of histogram, what happens is that along x-axis we take the class intervals, and along y-axis we take the corresponding frequency. So and we represented it in a bar form. Okay, so earlier in this contest what we had done is that we had marked this in bar form, but here the classes were not continuous. Okay, suppose that we have a continuous class, say x takes values from age of a certain student. Suppose that they fall in particular age of 0 to 10 and 10 to 20 and 20 to 30 and 30 to 40. This is the age group, and corresponding to this age group we have 5, 8, 3, 2, like that. Okay, so if I have to mark this in this age group, and there is a data of this one of continuous frequency distribution data, and if I want to represent this data, then what I do is I draw a histogram. Okay, so I mark from 0, then I mark it as 10, then I mark it as 20, then I do it as 30. Okay, 30 to 40 I marks. Then to something 2, 4, 6, 8. So corresponding to 0 to 10, what I do is that I draw 0 to 10 I have 5, so I draw in this way, and 10 to 20 I have 8 and I draw in this way, and 20 to 30 there are 3 people, then I draw in this way, then 30 to 40 I have 2 people, then I draw in this way. Okay, this represents a histogram. This is the example of histogram. So here the class intervals are taken in the x-axis and frequencies are taken along the y-axis. I hope that the idea of histogram is clear, and in 1 or 2 exams also drawing histograms were asked, and you can draw easily a histogram by considering this example. So I will write. So in histogram along x-axis classes are taken and along y-axis frequencies are taken. Construct a rectangle of proportionate length. Okay, this is the basic idea behind drawing a histogram. So I think that the idea of histogram is also clear to you. And these are some of the major techniques which are used in pictorial representation of a data. Okay, so there is one more method in representation of data, but this is not so important, but we will just look into that also. Okay, that is by the method of frequency polygon. Okay, by the method of frequency polygon. The idea is very intuitive. You know that also. Okay, here suppose that I have a class interval of 0 to 10, 10 to 20, and 20 to 30, and 30 to 40. So last day I have said about the midpoint of this data. So here 5 is the midpoint, and here 15 is the midpoint, 25 and 35, these are the midpoints, and corresponding to this class I have corresponding frequency as 5832. So what I do is that suppose I have 0 to, I take the midpoints 5, 15, 25, 35 of the corresponding class, and to corresponding class I draw just a straight line. Okay, suppose that I have 2, 4, 6, 8, then corresponding to 5 I have 5, then corresponding to 15 I have 8, so I draw a line simply. Okay, then corresponding to 23 I have 3, so I draw, and corresponding to 35 I have 2, so I draw just a straight line correspondingly. So this method is called as frequency polygon. Okay, so what happens in a frequency polygon is that in frequency polygon along x-axis midpoint of the class is taken and along y-axis we take the corresponding frequency or proportionate corresponding frequency, and these frequencies are joined by straight lines. This is the idea behind the frequency polygon. Okay, this is the idea behind the frequency polygon. I hope that the idea is clear to you. So this ends up with the representation of data. Okay, we had seen the two methods. One is by the numerical method and another one is by the pictorial method. I hope that the idea of representation of data is very clear to you. But we have some more time left. So what I do is I move on to next chapter. That is we will move on to the next chapter. Okay, coming into the next chapter is central tendency. Okay, central tendency measures or simply central tendency. So you look into what do you mean by central tendency and what are different central tendency measures associated with your syllabus. Okay, central tendency can be viewed as it is the tendency shown by statistical data to cluster around central part of the distribution. This is the basic definition of central tendency. The main idea is that suppose that consider an example. I have two data sets. Okay, in data set 1 I have mark such as 135. Okay, 135. Here the mean of this data is the main idea behind the central tendency. There are many 1 minute here we will talk about different measures of central tendency. Different measures of central tendency are mean, median and mode. Okay, so we have to locate. So in central tendency what we do is that so if we have a set of data, this data should should concentrate at a point. So that is നമ്മളിപ്പോൾ ഒരു അസംബ്ലി എല്ലാം നടക്കുകയെന്ന് വിചാരിക്കുക. പല ക്ലാസ്സിൽ നിന്ന് എന്ത് ചെയ്യും, അസംബ്ലി എല്ലാം നടക്കുമ്പോൾ പല ക്ലാസ്സിൽ നിന്ന് നമ്മൾ ഈ ഒരു അസംബ്ലി നടക്കുന്ന ഒരു ഗ്രൗണ്ടിലേക്ക് വരുന്നൊരു ഇതൊന്ന് ചിന്തിച്ച് നോക്കുക. അന്നേരം ഒരു ക്ലാസ്സിൽ നിന്ന് ഇങ്ങോട്ടേക്ക് വരുന്നു, മറ്റേ ക്ലാസ്സിൽ നിന്ന് ഇങ്ങോട്ടേക്ക് വരുന്നു, അങ്ങനെ നടുക്കിലുള്ള ക്ലാസ്സിൽ നിന്ന് ഇങ്ങോട്ടേക്ക് വരുന്നു. അന്നേരം ഈ ഒരു പോയിന്റിലേക്ക് എന്താണ് എല്ലാ ആൾക്കാരും കോൺസെൻട്രേറ്റ് ചെയ്യുന്നത്. അങ്ങനത്തെ ഒരു കൺസെപ്റ്റിനെ വിളിക്കുന്ന പേരാണ് സെൻട്രൽ ടെൻഡൻസി എന്ന്. ഒരു സെൻട്രൽ പാർട്ട് ഓഫ് എ ഡാറ്റേൻ്റെ സെൻട്രൽ പാർട്ടിലേക്ക് വരുന്ന ഒരു സാധനത്തിനെ വിളിക്കുന്ന പേരാണ് സെൻട്രൽ ടെൻഡൻസി എന്ന്. ഓക്കെ, ഏതാണോ ഡാറ്റയുടെ സെൻട്രൽ പാർട്ട്, ആ സെൻട്രൽ പാർട്ടിലേക്ക് വരുന്ന ഒരു സംഭവത്തിൻ്റെ പേരാണ് സെൻട്രൽ ടെൻഡൻസി എന്ന്. നമ്മൾ ഈ ഒരു അസംബ്ലീൻ്റെ ഒരു ഐഡിയ ഒന്ന് മനസ്സിലാക്കിയാൽ മതി. അതായത് പല ക്ലാസ്സും നമ്മളിങ്ങനെ വരുന്നു, ഒരു ക്ലാസ് ഭയങ്കര ദൂരമായിരിക്കും, മറ്റേ ക്ലാസ് ഭയങ്കര ദൂരമായിരിക്കും. എന്നാൽ ഈ എല്ലാ ക്ലാസ്സും കൂടിയിട്ട് എന്താണ് ഒരൊറ്റ ഡാറ്റയിലേക്ക് ഒരൊറ്റ സെൻട്രൽ പോയിന്റിലേക്ക് വന്നിട്ടാണ് നമ്മൾ അസംബ്ലി കൂടുക. ആ ഒരു ഐഡിയ മനസ്സിലാക്കി കഴിഞ്ഞാൽ അതാണ് ഒരു മിഡ് പോയിന്റിലേക്ക് വന്ന് ചേരും എന്നുള്ളൊരു രീതിയിൽ ഒന്ന് മനസ്സിലാക്കിയാൽ മതി. അതിനെ വിളിക്കുന്ന പേരാണ് സെൻട്രൽ ടെൻഡൻസി എന്ന്. നമുക്ക് ഡെഫിനേഷൻ എഴുതാം, എന്നിട്ട് അതിൻ്റെ മെഷേഴ്സ് എന്തെല്ലാമാണ് അത് നമുക്ക് ഡിസ്കസ് ചെയ്യാം. So moving into central tendency. So as I have already defined it, central tendency uh, central tendency is the tendency of statistical data to cluster around central part of the central value എന്ന് പറഞ്ഞാൽ മതി. സെൻട്രൽ പാർട്ട് ഓഫ് ദ ഡിസ്ട്രിബ്യൂഷൻ ആയാലും തെറ്റൊന്നുമില്ല, സെൻട്രൽ വാല്യൂ എന്ന് എഴുതിയാൽ കുറച്ചും കൂടി ക്ലിയർ. So central tendency is the tendency of statistical data to cluster around central value. Okay, for example, there are many measures of central tendency. We will write some of the measures of central tendency are measures of central tendency are, we will discuss in detail. First one is mean, second one is median, third one is mode. Now we will discuss in detail about the three measures of, or the three important measures of central tendency, okay, which are mean, median and mode. So it is nothing but tendency of statistical data to cluster around central part of distribution. Okay, I think that the idea is clear to you. Okay, so now we move on to the mean of the distribution. So as you know that now I consider the three cases earlier which I have said, that is three numerical representation techniques, okay, which were raw data, and for each technique we have to find out what is the mean of the data. That is for raw data, then continuous distribution, then discrete distribution. So what and all are the how we can find out the mean for three situations. So that we will discuss now. Okay, so as the first case we will discuss that of raw data. Okay, first we will discuss of raw data. So in raw data we have observation as x1, x2 and n. Suppose there are n observations, x1, x2, etc., xn. Then we define the mean of this n observation as summation xi by n. So I will define what and all are these things, and with an example you will be able to understand more. Okay, the mean is defined as summation xi by n. Okay, so I will define first of all for an example. Let us consider the example where I have 1, 2, 3, 4, 5. This is my raw data. Okay, this is my raw data, and I have to calculate the mean of these data. Then what I do is that the mean is given by sum of each observation, that is 1 plus 2 plus 3 plus 4 plus 5. Then as you will calculate 1, 2, 3, 4, 5. There are 5 observations. So here n is the total number of observations. N is the total number of observations, and summation xi is nothing but sum of all the observations. Summation xi is nothing but sum of all the observations. Okay, so in this case we get it as 2 plus 1 3, 6, 10, 15 by 5. Okay, it is nothing but 3. So it is midpoint, as I have already told you that the mean here, these points will try to concentrate on this central part of this data. Okay, this is the idea. So I consider another example and I find out the mean of -1, 0, 1, 2 and 3. Okay, suppose I want to get the mean, then I have to take total minus 1 plus 0 plus 1 plus 2 plus 3 divided by 5. Okay, then I have 5 by 5 equal to 1. Here also 1. Okay, that is I move into central part of the distribution of this data. So in this way we can find out the mean of a raw data. So mean of the raw data is found out by such a fashion that total number of the observation sum of all the observation by total number of observation. This is the formula to calculate mean of the distribution. So I think the idea is clear. It is nothing but mean is nothing but sum of all the observation by total number of observation, that is summation xi by n. I think that the idea of mean is very much clear to you in the case of raw data. Okay, then we move into next situation where we have a discrete frequency distribution. Okay, discrete frequency distribution. So in the case of discrete frequency distribution you will have, so in the case of discrete frequency distribution, so what happens in this case is that here you will have x values and corresponding to x values you will have f values, frequencies. Okay, so suppose that you have 1 2 3 4 and corresponding to f also you have 1 3 2 1. Let it be the corresponding table. So this is my DFT and I will now explain how can I find out the mean using discrete frequency distribution technique. Okay, so what happens is that suppose that mathematically I can say that x1 x2 etc xn be n random variables with f1 f2 f3 etc fn as n frequencies, then I can say that the mean is obtained by summation xi into fi. I ranges from 1 to n divided by summation fi. Okay, this is the idea behind mean of this discrete data. So I will find out that how to find out the mean of this data. When you find out mathematically it will be very easy. So what I have to do is that I have to multiply xi fi. Okay, so here I have xi, here I have xi, so I have to calculate xi fi. So 1 into 1 1, 3 into 2 6, 3 into 2 6, 4 into 1 4. So here the total number is 6 plus 1 7, 6 plus 1 7, 17. Okay, 17 is total. So 1 into 1 plus 2 into 3 plus 3 into 2 plus 4 into 1 divided by summation of I. 1 plus 3 plus 2 plus 1. Okay, 1 plus 3 plus 2 plus 1. This is nothing but total number of observation. If you if you look into the previous class, I have already mentioned how we had taken raw data into a frequency data, discrete frequency data. So there were repeated, and each repeated was assigned how much times it was repeated. Here the 2 had been repeated 3 times, the 3 had been repeated 2 times, and 4 had been repeated 1 time. So it is nothing but total number of observation. So here what we obtain is that 17 by plus 2 5 6 7 is the answer of mean. Okay, in this way we can calculate mean of a discrete frequency distribution. So I will consider one more example. Okay, suppose I have another example where suppose that for any example let us consider uh, x takes 0 minus 1 0 1 2 with corresponding frequency c 2 1 2 1, let it be. So how we calculate xi first. So 2 into minus 1 it is minus 2, and it is 0, it is 2 into 1 2, 2 into 1 2. So here the total is 2 plus 2 4, 4 plus, so it becomes 2, total number is 2. Okay, so in easier way what you can do is you can write it in column wise, then it will be more easy. F, and it is xi fi, okay, or xi fi. So here it takes minus 1 0 1 2, and here it takes 2 1 2 1. So it is, you can write in column wise, then it will be more helpful for you. Okay, so if I take 2 plus 2 4 5 6 observation, so the total number of observation here is 6, and its summation is minus 2 0 2 2. So here the total is 2, since 2 and minus 2 get cancels. So I get the mean as 2 by 6, or it is nothing but 1 by 3. Okay, I think the idea of mean in the case of discrete distribution is clear to you, and if you have any doubt we can discuss in our discussion session, which can be conducted after this video. Okay. Moving on to the case of continuous frequency distribution. In the case of continuous frequency distribution, so distribution. Okay, so what happens is that we take the midpoint, suppose that we take the midpoint and we do the corresponding method same as that in the case of discrete frequency distribution. So ഇതിൽ ക്ലാസ് ഇൻ്റർവെൽ ആയിരിക്കും, ക്ലാസ് ഇൻ്റർവെല്ലിൻ്റെ പകരം നമ്മൾ മിഡ് പോയിൻ്റ് എടുക്കും. മിഡ് പോയിൻ്റ് എടുത്തിട്ട് അതേ രീതിയിൽ ചെയ്യും. ഏത് രീതിയിൽ? നമ്മുടെ ഡിസ്ക്രീറ്റ് ഫ്രീക്വൻസിയിൽ ചെയ്ത രീതിയിൽ അതേ രീതിയിൽ ചെയ്യും. ഇവിടെ എക്സ് എന്ന് പറഞ്ഞാൽ ഇപ്പോൾ ഉദാഹരണത്തിന് suppose that x takes values from let it be 0 to 10, 10 to 20, 20 to 30, 30 to 40. So frequencies are 2 1 2 1. So what I do is I take x's as midpoint of this. So midpoint is 5 15 25 and 35, and corresponding to xi I have fi as 2 1 2 1. So total number is 6. I calculate xi fi, 5 into 2 10, 15 into 1 15, 25 into 2 50, 35 into 1 35. Okay, if we calculate we will get, okay, 35. So if we will calculate we will get the overall, and we can find out the mean as summation xi fi by fi. So summation xi fi is obtained as 35 50 85 85 95 100 110. Okay, so I think that my calculation is correct, or you can correct in your notes. Okay, so this is the mean of this distribution. So this is the case where, as in the case of continuous distribution, how to calculate the mean of a particular data. In the case of continuous frequency distribution, you can calculate in the same way as in the case of discrete frequency distribution, that is xi fi divided by summation fi. This is the formula which is used to calculate the mean of the distribution. Okay, so we can end our class by this. Then we can have a small discussion, and after that if you have any doubt then I think that you may please ask. Okay.